It's a little sunny today. I put on a hat, keep the sun off my head. 8 and 5, lesson 9, examples of functions from geometry. This is a little different than everything we've been doing so far. This is bringing back a little geometry. You're going to have to think a little bit about shapes and adding them together, subtracting them, remembering a few formulas. These formulas are key things that you have to know going into high school. A few key functions and formulas, and we'll go over those as we go through the lesson. So let's hit it and go to our screen and talk about the 4 things that we're going to learn today. So here are the keys. There are 4 key, these are just examples of functions from geometry, and we're going to talk today about 4 key problem types and concepts. So 4 key problems, and these are, everything we're going to do today is homework help. So the first idea is the volume. You need to know the volume of a rectangular prism is the length times the width times the height. So rectangular prisms are things like, they're 3-dimensional, so things in the real world, and things like a juice box is a rectangular prism because it has a length, a width, and a height, and each side is a rectangle, right? It has 6 sides, and each side is actually, if you look at it straight on, is a rectangle with a right angle. And so that's what a rectangular prism is, a 6-sided object with all right angles. And so it has a length, a width, and a height. And so you can think about it in the width. You have a width. The width at the bottom is the same as the width at the top, and is the same at the width on this side. Similarly, the height is the same in the front and the back, and on the front, each of the front sides. And then the width is the same on the front and on the back. Now, similarly, you could have a box of tissues. So this is also a rectangular prism. Forget about the tissue part, but the box itself is a rectangular prism, and its volume, the amount of tissues or the amount of air that would be inside this box if it was empty, would be the length times the width. Well, the length times the width times the height. It doesn't matter what you call the length, the width, and the height. You just got to be consistent. So if this is the length here, then this is also the length, and then this is also the length over here. And then the height would be this, and this, and this. And these would all 3 be the same. And then even this back side here that you can't see, there's a height there, and that would be the same. And then the width, similarly, that all of these widths would be the same length. And a building, buildings that are outside, that are rectangular in nature, sometimes they have different shapes, but most buildings are rectangular. So you could calculate the amount of air that would fit inside a building by just multiplying the length times the width times the height. So 50 times 40 times 30 would be your answer. And the units would always be, because it has 3 dimensions, you use this meters cubed thing. Right? Length, because it's only 1 dimension, it goes in 1 direction, is just meters. Area is always talked about meters squared, but then volume, when you talk about the amount of air that will fill something up or the amount of water that will fill something up, is always, the units are always meters cubed or centimeters cubed or inches cubed. You have this 3 thing because it lives in 3 dimensions. Okay. The second thing we're going to talk about is the volume is often calculated for compound. They call these compound objects by adding the rectangular prisms together. So there's no formula to help me figure out the volume of this object by just doing 1 simple multiplication. In this case, I need to break this down into 2 objects, object 1 and object 2, and then I add the volumes together. And same thing over here. This is another rectangular object. You can see that if this is 4, and this is 4, and then this would be 4, because this over here is, or sorry, this would be 6. because this is 6, this is 6. So this whole distance is 6. So this top thing would be 4 by 4 by 6. And the bottom thing is, the length is 10 by 4 high times 6. Doesn't matter what order we multiply the length, widths, and heights in. So we would add those together. You'd get this answer, you get this answer, and you'd add them together, and that would be the volume. So we'll have some problems along these lines too. Now we're going to go to something actually a little bit easier. We do it a little bit out of order maybe. We go back and we're going to do area. So area is just 2 dimensions, right? There's no, this isn't, you know, it's not a 3-dimensional object. This is just a 2-dimensional object, like a tabletop or the amount of paint you'd paint on the wall. And here, we're not going to talk about just straight area formulas because you learned those in 6th and 7th grade. But we're going to talk about how we can, how area, kind of like volume, we can calculate this by, oh, I got these pictures backwards. This picture should go here and this picture should go here. So let's just do that right now. Sorry about that. So sometimes areas can be calculated by addition, right? So we could add 2 pieces, like we can't figure out what this, there's no formula to figure out what this object is, or the area of this object. But look at this. If I just kind of make a line right here, now I have a rectangle 1. And let's see, if this is 3 and then this whole thing is 6, then this is 3 to here. And then this must be 3 going here. It's 3 plus 3, there's our 3 and 3. And that 3 plus 3 makes up our 6. So here we could say, well, we have rectangle 1 and rectangle 2. And rectangle 1 is 3 by 5. So that's 15 square feet. And then rectangle 2 is 3 by 2. So that's 6 feet squared. So our total area of this whole thing would be 15 plus 6, which is 21 square feet. And we'll do some problems like this. I'm just reminding you, these problems, we actually did this problem here in 7th grade. This is a 7th grade standard, and this is just a reminder. But sometimes you can't do an addition problem when you're finding areas. Sometimes the easiest thing to do is do a subtraction problem. So look at this problem. If we were trying to find, if the purple was this whole piece, we would know that the area would be 9 by 12, right? 9 by 12 for the whole thing. But we've taken out this little rectangle here, and this rectangle has dimensions of, let's see, well, that's 9 by 12, but we've taken out a piece that's 7 here. We know that's 7 because the whole thing is 12, and this piece here is 5. So that's 7. And then this piece here is what? This piece here is 9 minus 4, which is 5. So this rectangle has an area of 5 by 7 that we've taken out. And so we've subtracted this from this whole rectangle, and that's a half of base times height, half of 5 times 7, which is equal to 17 and a half. 35 over 2 is 17 and a half. So the whole area of this thing is 9 times 12 is 108. And we're going to subtract off this 17.5, and we're going to get some answer here. We're going to have a few, we'll do a few of these as well. So these are the 4 types of problems. I've actually given you, we've actually worked a few problems here, but I'll go into a little bit more depth as we go to each problem type in the lesson. And if you know how to do one of these problem types, just skip over the specific problem and we'll move on to the next. And you can personally just move on to the next problem type. Okay, let's solve these guys. We'll solve them in, we'll solve them in green. So remember, the volume of a rectangular prism says it's kind of how much, it's multiplying the length times the width times the height. And the question is how much air would fit inside here, or how much water would fit inside here if you filled the whole thing up? That's what volume is. Volume is like how much water fills something, or how much air fills something. So the volume of this object is, the volume is equal to the length times the height, or times the width, times the height. And it doesn't matter what you call the length, the width, and the height. Some people get all hung up on what is the length, width, and height. And all you got to do is multiply the 3 dimensions together and get your answer. So we'll just call the long thing the length. The width we'll call this thing. And the height we'll call 4. And we'll come up with our answer. And we're going to be using some calculators today if you want. Feel free. And the answer here is 72. You can do it in your head. You can do it, 12 times 7, or 12, sorry, 3 times 4 is 12. 6 times 12 is 72. I can do that one in my head. Some of these I'm not going to be able to do in my head. And it's okay to use calculators today. Okay, so because each dimension, and this is really important, because each dimension is centimeters, our units, whenever we're doing a volume, we have to write our units. And remember, it's centimeters cubed, or whatever cubed. Volume, your answer is always going to be in cubic units, because you have 3 dimensions. 3 dimensions. So that's where we get our 3 from here. All right. Now let's look at this differently. Let's look at the problem a little differently. Now, in this case, we know the volume, but we don't know how the height. So we have this fish tank of water. And on any of these, just notice you can stop, you can pause at any time and try these on your own. And I encourage you to do so. I'm not going to tell you every time to pause and try. We're just going to work through them. But I encourage you to try it if you think you know the answer, because you're going to learn it better if you try it yourself. If you just listen to me talk to you, you're going to know it about a tenth as well as if you do it yourself and get it right or wrong. Just try it. Okay, so let's move this up here a little bit. Okay, so now the volume is 2,079 meters cubed. How deep is the water? So in this case, we know that volume is equal to, length times width times height. And we know the volume. We know this one is 2,079. And we know the length is, we'll call this the length, and we'll call this the width. And the height we don't know. So if our length is 33, our width is 9, and we don't know our height, we're going to have to solve for height. So let's figure out this. We know how to solve these types of problems. We just multiply our 33 by 9. I'm using a calculator, I'll tell you. I'll just admit it right now. And that's 297 H, and that equals 2079. Now to get to H, I'm going to divide both things by 297. So 2079 divided by 297, and I get 7. Oh, nice even number. And what is it? 7? If these were meters cubed and everything I'm doing is in meters or meters cubed, my answer must be 7 meters high. So our height is 7 meters. Okay. Number 3 is similar to number 2, except I haven't told you a key piece of information, or I'm making you do one extra complicated step, or maybe I'm just making you think a little bit harder. So I have water in this object over here, and I can kind of calculate how much water. But if I take all this water out and I pour it in to this over here, the question is how full how high would the water be? Right? It's not going to fill it all the way up. Or maybe it would. Maybe it would overflow it. So your job is to figure out how high would the water go. Step 1, so I'm going to suggest you pause and try this one. And the key thing is to figure out how much volume is over here. What's the volume over here? And then we can figure out what the volume will be over. We know this it'll be the same volume, so then we can figure out how high over here it will be. So why don't you pause and try. Now I assume you're back. So let's figure out the volume. The volume we know is the length times the width times the height. So it's 2 times 4 times 4, and that equals 32 cubic centimeters. So if I take 32 cubic centimeters and pour it in over here, I know that it will fill in this direction. And so my volume is going to be my length times my width times my height. It's not going to go all the way at 5 centimeters probably. So let's see. So 32 is my volume. That'll be the water that all gets dumped into here. And that will equal 8 times 2 times my height. So 32 equals 16 times my height. Okay, this is nice. We're going to divide by 16, and I get 2 equals my height. And 2 what? 2 centimeters. So it'll be 2 centimeters high. Okay, right? Because 2 times 8 times 2 will be 32. All right, so hopefully that's straightforward. Makes sense. There's more practice in your homework set. Now the second thing is you're going to say, well, sometimes our volume is calculated by adding 2 rectangular prisms together. And I have 2 problems along those lines. And in this case, I've told you that the side of each block is 1. So this is 1, 1, and 1. So this whole side is 3. You know, here we got 1, 1, 1, 1. So this is 4, and this is 4. It's 1, 1, 1, 1. Okay, I'll let you try this one. Okay, so let's see. We have this green section, and we have this yellow section. Now, one thing you can do is you could just count up the blocks, and you could get your volume. And we'll do it that way in a second, and we'll just verify we get the right answer. But this green thing, well, what's its length, width, and height? Well, let's not do green. Let's use red, pink, so we can, no, let's use blue. So this is 2 by 2 by 4, right? Our dimensions on this guy are 2, 2, and 4. So our green equals 2 times 2 times 4, which is 16 units cubed. And we don't know what the units are, so I'm just going to call them units cubed. And then the yellow is, well, that's 1 by 4 by 4. 1 by 4 by 4. That's also 16 units cubed. So we just add those together. So if we have 16 blocks and 16 blocks, we have 32. Units cubed. Let's count them up. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And behind this one, we have 10, 11, 12. Sorry, 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 yellow blocks, correct. And the green ones, we have 1, 2, 3, 4, 5, 6, 7, 8 on top. And then right underneath them, we'll have, the same number, 9, 10, 11, 12, 13, 14, 15, 16. So there we have our 32 units, whether we counted them by hand or whether we used our volume formula. Okay. Let's look over here. What is the volume of this object on the right? Now, I'm going to give you a hint. Let's just cut it right like this. And let's think about it. If this is 2 and this is 2, and this is a rectangular prism, this back here is going to be 2. And this over here, think about what this has to be right here. Okay, pause and try. All right, I assume you've paused and tried, so let's come back. So if this is 2 and that's 5, then this side must be 3. 3, and this is 3. These are all 3. That's our length. So let's look at object 1. Let's switch colors again. So this is object 1 and this is object 2. So object 1 has a volume of 2. Everything's one high. This is 1, 1, 1. So we get 1 by 2 by 5. So that is equal to 10 meters cubed. Now the volume of 2 is equal to, let's see, the length is 3, the width is 1, and the height is 1. So this is 3 meters cubed. So our total volume is 13 meters cubed. Okay? Good. Hopefully this is going well for you. So that's our volume problems. You'll have more again on your problem set. Open, cancel, open. All right, let's go back to area. So area is a little bit easier to think about for some people. So let's do this one. We're going to, it's purple. Oops. Why is it not giving it to me? There we go. All right, so we got 3 problems. Find the area of these 3 objects. So the key thing here is going to be to cut these objects into simple rectangles, triangles, and semicircles. So let's remind ourselves that the area of a rectangle is length times width. Of a triangle is a half of base times height. And then of a circle equals pi r squared. And then a semicircle then would equal 1/2 of pi r squared. Okay, and so this here is a semicircle, right? Because we have this, we're only going to be talking about this. So this would be a if this was a circle, but it's not. We're going to take a rectangle and then add it to a semicircle, and think about what the radius of this guy is going to be. It's going to, the radius is going to be probably half of this guy. Okay, so I'll let you solve these guys. Remember, think about, I'll give you a hint here. You might want to just, here's some good cuts on these objects. So you can cut them in 2 and then calculate. Okay, so I assume you've paused and tried this. Feel free to pause and try and go 1 at a time, or do all 3 if you want. So let's look at this. So we're going to cut this one here. And so if we cut this one here, and this is 3 down here, then this is 3 up here, and this got to be 3 here. So if the area of a rectangle is length times width, this one here is 3 times 5. So this one's 15, and this one's 3 by 2. So this one's 6. So we have 15 plus 6 equals 21 square feet. And there are a lot of, you'll get a lot of problems like this. Again, you were doing these problems in 7th grade, these kind. And same with this kind here. So here I'm going to cut it like this. So if this is 14, and this down here would be 14, and this is 22, then this has to be 8. Make sense? And this here again is 12. So we have a rectangle. Let's not call that 1. Let's just call this R for rectangle, and that's T for triangle. So let's see. The rectangle is 12 by 14. And that's 168. Remember, the area of the triangle is 8, 1/2. 1/2 of base times height. The base is 8. The height is 12. So that's 48. And these are centimeters squared, right? 2 dimensions. So we have squared. So let's add 168 and 48. 6, 1, 1. 216 centimeters squared. Okay, good. All right, on this last one, we have 2 areas. We have a semicircle, so we have a semicircle, and here we have a rectangle. So the rectangle is easy. We've been doing those now in each of the last few problems. So the rectangle is 20 times 30, length times width. So that's just 600 millimeters squared. Now the semicircle is 1/2 of pi times r squared. And now our r is what? If this whole thing is 20, our r is just our radius of our circle. The distance from the center to the edge is just 10. So we go 1/2 of pi, irrational number, times 10 squared. So that's 10 squared is 100. So let's see, 1/2 of pi times 100. Let's rearrange. 1/2 of 100 times pi. Let me write this a little bit neater. 100 times pi. 1/2 of 100 is 50 pi millimeters squared. Now we can't combine, we can add these together, but we can't combine things with pi's in them with things that don't have pi's in them. That's we've done in another lesson. Not going to go over that again. So 600 plus 50 pi millimeters squared. That's our answer. So that's how big. This is a key. You know, for those of you who play basketball, this is the key in basketball. And it's probably like a key for, if like little ants were playing basketball, because it's pretty small. Millimeters are not very big. Okay, so that's the third. Area can be added together. You've got to just think about how can you break down the objects into objects that you know better. Okay, so now let's go on to the final piece. And this says that area sometimes, when you break things down, you break them down and you then end up subtracting them rather than adding them together. This one here is subtraction. The first one, whoops, why can't I? That one is a subtraction problem, and that one is clearly a subtraction problem. But this one can be done by subtraction or addition. And we'll look at that here in a second. Okay. So the idea here is if I just wanted to find the area of a big section like this, I'd have a big piece of cake. Well, that piece of cake is going to be 9 by 12. Now, let's say that someone comes along on this 9 by 12 cake and they chop off a corner piece like this that has some amount. Well, if we had our big piece, and let's say that was 9 by 12, which was 108, if their piece here is 5 by 7, or let's say it's 5 by 7, and so that's 17.5 because it's 1/2 of times 5 times 7, which is 35 over 2, which is 17.5. So they have this 17.5, square meter section of cake. Well, if the original piece was 108 and they took out 17.5, then the rest of the area is 108 minus 17.5, which is equal to 90.5. So 90.5 is what's left over. Okay? That makes sense. So we kind of did this problem at the outset. I don't know what that 2 was for. Okay, so it looks kind of like this. So we took the big rectangle, subtracted off the little triangle, and we got 90.5 meters squared. I want you to solve this problem here by taking this big rectangle and then subtracting off this little piece. Subtract this off. Then we can do it by adding and see if we get the same answer. And we'll just do that. Of course, we're going to get the same answer because that's math, and math is perfect. So, pause and try. So, if we take the whole piece, we have 9 by 6. The whole rectangle is, if we take this whole rectangle, we have 9 by 6. And that's 54 units squared. Why do I say units? Because there's no units written here. So you always have to declare your units. Over here we have meters. Over here we have feet, which are declared for you. But if it's not declared, you have to write in this thing called, you just say units, and then you just say units squared if you're talking about area. So now let's figure out this little piece. Well, this little piece is 6 here. And well, if this is 4, then this must be 2. So we're going to subtract this piece to find out what the big piece is. We have a big sheet cake, and someone just took off a 2 by 6 piece. So they took off 12 units. And so what's left is 42 units squared. Now let's do this same problem, but let's do it by adding. And let's make sure that we come up with the same answer. They take all these little pieces off. Whoops, not that one. Okay. So now let's do this by addition. So I'm going to go like this here, and we'll chop it this way right here. So if this whole piece here is 6, then this piece here is 6, and then this piece here is 3, right? Because the whole thing is 9. And so here we have 6 by 4. And so we're just finding out what this is, and then we're going to figure out what this is and add them together. So this is part 1, and this is part 2. So part 1 is 4 by 6. So there we go. 6 by 4 is 24. And then 3 by 6 is this other piece. So 3 by 6, that's 18. And so if we add those together, we get 42 units squared. Cool. So this is a neat problem because it really lends itself nicely to either a subtraction problem or an addition problem. This one over here is pretty much a subtraction problem. There's really, I mean, you could try and break it into more complicated pieces, but I just don't know. Now you have 3 pieces. This is much more naturally a subtraction problem. This went either way. Now let's go to this one over here. Now here what you've done is you have this giant circle. You've taken this giant circle and you've taken out the middle. So you have a donut. You're trying to figure out how big this thing is. And there's no formula for figuring out a donut shape without, the only way you can really figure out the area is by finding how big the entire circle was before you took out the middle, and then subtracting out the middle piece. And so the area of the big circle is pi times r squared for the big circle. And then you're going to subtract off pi r squared for the little, for this circle, for the white circle. So we got to figure out what the big circle's radius is. Well, you know that if it's 10 from the middle of the little circle to the edge of the big circle, or the little circle, and then it's another 4 to the outside, you have a radius. The big radius is 14. And the little radius, they tell you, is 10. So the big circle would be pi r squared, pi times 14 squared, and we're going to subtract off pi times 10 squared. So 14 squared, we, some of you probably have that memorized. I kind of have it memorized, but then I sometimes have to just validate that I haven't forgotten. It's 196 pi. So 196 times pi, and we're going to subtract off 100 pi. And so we get 96 pi, and these are square feet. And there you have it. So we've worked a lot of problems. We maybe did a little bit less theory today and a little bbit more just straight to the problem types. I didn't maybe do a ton of explaining like I normally do. Let's take that hat off. It's just a little sunny today. I got a little too much light up here. I don't know. Something wrong with the lighting in this room today. But at any rate, we did a lot of problems. Hopefully they're helpful. That's pretty much what you're gonna be doing on your problem set. And I look forward to coming back and teaching you 8M5 lesson 10 and 11, and then we go right into 8M6, and that'll be the end of the year. So you've done a lot. Hopefully this lesson was useful. Let me know. Give me a like. Subscribe to the video. Leave me comments. I love teaching math, and I really want, it's the key. It's really a key to high school math, unlocking geometry, advanced algebra, trigonometry, pre-cal, calculus. All this stuff that we're doing is so key. Really getting those building blocks ready so that when you get into high school, you can jam at math. All right, enough from this. Enough from me.